We might someday be known as the generation that stood knee-deep in garbage, firing rockets at the moon. Water pollution may flow away to bother someone else downstream. Air pollution may blow away to foul the atmosphere downwind. But the third pollution, solid waste, just piles up in staggering quantities. On the average, each of us generates 4.5 pounds of refuse a day, nearly a ton a year. New York City's Department of Sanitation has 14,000 employees, 1,200 trucks, collecting nearly 10,000 tons of household refuse every day, 3 million tons a year. Then there are special collections of trade waste, bulk refuse, abandoned cars, street sweepings, litter, and leaves. All told, New York City disposes of over 6 million tons a year, and much of it is buried in this 3,000-acre sanitary landfill on Staten Island. And when the earth cover has been spread, you'd never know that the remnants of millions of dollars worth of consumer goods lie buried below, patiently waiting for the curious eye of some future archaeologist. Most urban communities in America have a significant solid waste problem. Everyone energetically disposes of his unwanted material. 150 million tons a year moves into incinerators, landfills, or dumps. But there are conflicting criteria. Don't put a smelly dump or a busy landfill near my home. Don't burn the stuff and create air pollution. Don't tax us so heavily for garbage collection and disposal. This burning dump in Washington, D.C. converts solid pollution into air pollution. The bottom layer of our atmosphere, 6 miles high, contains 70% of the Earth's total air mass, which are controlled by numerous variables. The worst possible situation is a stagnant pool of air hanging over a big city. A typical city skyline with a wisp of smoke dispersing into the atmosphere. New York City has over 10,000 individually owned flue-fed incinerators. Despite the acknowledged health hazard, every year automobiles, industry, power plants, furnaces, and refuse disposal systems throughout the country vent 125 million tons of pollutants to the atmosphere. Improper methods of solid waste disposal can also generate water pollution. But even more insidious than the effect on surface waters is the possibility of groundwater pollution. Rain on dumps and even seepage through poorly engineered sanitary landfills can leach dissolved pollution into subsurface water systems. The The National Academy of Sciences National Research Council comments that pollution is a resource out of place. This garbage, which could be converted to compost with fertilizer value, is discarded instead. A nuisance, a hazard to health. The United States Public Health Service warns that flies, cockroaches, and mosquitoes carry disease. And so do rats. The solid waste problem is an economic paradox. Reluctantly, we spend over $3 billion a year to collect and dispose of our refuse. Of all public services, only roads and schools cost more. And yet our efforts to salvage used materials with value are inadequate. Municipalities frequently go it alone rather than organize regional systems, which would be more effective and efficient. Industrial support is needed to stem the flow of one-way bottles and non-degradable plastics and aluminum cans which compound the problem. Cities, counties, municipal regions, states, all need to face up to this very real requirement. Some tips on solid waste management. The Mission Canyon Sanitary Landfill is one of several serving Los Angeles. It receives 3,000 to 4,000 tons of refuse a day. Its operation is one of the best in the world. A sanitary landfill is more than a dump or a landfill. A good sanitary landfill is an aesthetically acceptable, coordinated operation which receives and quickly buries refuse to prevent air pollution by smoke and odor, disease transmission by rodents and vermin, and other nuisances and hazards. Big earth movers spread clean soil over the refuse after it has been placed, completing coverage by the end of each day's operation. Compacting the fill will diminish drainage problems, reduce subsequent settlings, and prevent odor, rat infestation, and the emergence of any hatching fly larvae. While this ambitious operation is more expensive than open dumping, it can be satisfactorily conducted near residential areas, thus permitting closer location and reduced hauling costs. In some cities, as much as 80% of total costs are devoted to collection and hauling. And so the Los Angeles County Sanitation Districts transfer refuse to huge trucks, while strategically locating landfills throughout the metropolitan area. No one wants to live next to a dump, but what about a sanitary landfill? If it is properly operated, the nuisance is negligible. Many landfill areas are not subsequently developed intensively due to the possibility of slight settlement of the fill. Thus, instead of being surrounded by other development, the nearby homeowner can be next to a park or green space. By way of contrast, this excellent operation serving the smaller community of Waukegan, Illinois. It is privately operated and is located on flat terrain instead of filling a ravine. Incidentally, refuse collection and disposal must continue rain or shine, summer or winter. While some future technique which could recycle our wastes might be more desirable theoretically, the sanitary landfill is practical, economic, safe, and currently being used by many large cities and smaller communities. The incinerator without a smokestack. Many years ago, when incineration was first used to reduce the volume of refuse, the crude operation and offensive smoke from these furnaces caused extensive public opposition. While there are still many deficient operations throughout the country, today engineers are devising handsome, efficient, and nuisance-free incinerators. This new unit at Oceanside, Long Island, has a capacity of 750 tons per day. In addition to burning refuse, this incinerator includes a waste heat recovery complex, providing both power generation and saltwater conversion. The architect designed the building to appear to the casual observer to be a school or institutional type building. Even though refuse disposal creates only a small percentage of total air pollution, public operation of these facilities requires that they set an example. Accordingly, the town of Hempstead has incorporated a complicated network of large arresters which catch the fly ash before it can emerge from the stack as visible air pollution. By adjusting dampers, optimum velocities are maintained, permitting the scrubbers to clean the gases thoroughly. As a result, no tall smokestack is needed. Persons driving by the Oceanside plant would have a hard time guessing that this is the town incinerator. Just as the sanitary landfill is an improvement over open dumping, today's incinerator is merely an improvement over open burning, and further improvements are needed. Here, Professor Elmer Kaiser of New York University conducts working experiments at the Oceanside plant under sponsorship of the U.S. Public Health Service. The recently passed Solid Waste Disposal Act places a strong emphasis on research. Here at Oceanside, it was possible to use excess heat from the available waste to desalt ocean water at a lower cost than other locally available water supplies. Instead of an ugly single-purpose furnace, the town of Hempstead has invested in a sophisticated solid waste disposal plant with byproducts of electric power generation and water desalination. Ultimate future development of the potentials in this type of process might additionally involve water purification for public water supply and sewage treatment. At Manhattan College in New York City, a pilot plant built by the National Waste Conversion Corporation demonstrates some new techniques in composting municipal refuse. Mechanically shredded garbage and trash is the input material. Bulky objects are taken out first, and then metal is removed by magnets after grinding. Then the raw pulp undergoes complete aerobic bacterial digestion for a period of 48 to 60 hours. This composting process will convert refuse with as much as 85% paper content. Partially digested pulp is recirculated, acid or alkaline correction is made, and nitrogen, phosphorus, and potassium are added during digestion. The final product is a granular, free-flowing, dust-free material containing controlled quantities of plant food enrichment. It is an organic fertilizer, a saleable product designed for the home, lawn, garden market, or the farm. At Glendale, California, another pilot plant. This is the Lance Converter. Its input is shredded municipal rubbish, agricultural refuse, or industrial waste. These combustible materials are carbonized through a process called destructive distillation. This is a continuous flow, self-sustaining operation. One product is combustible gases. About 30% of these are fed back to sustain the process. The remainder are adaptable as fuel. The other product is charcoal, which can be formed into briquettes and also used as fuel. For example, a Lance converter can decompose 2 tons of wood scraps per hour, producing 800 pounds of charcoal and 100,000 cubic feet of gas, with a resultant surplus of over 50 million BTUs of heat. One of the few successful composting plants in the United States is at Altoona, Pennsylvania, where a Fairfield Hardy digester expedites digestion of municipal wastes by aerobic thermophilic action. This digester provides control over forced air to govern the self-generated temperature of the material during a 5-day digestion period. The digester is part of the equipment used by the Altoona FAM Corporation, a commercially successful converter of garbage, refuse, sewage, sludge, animal, and other wastes into a usable compost or soil conditioner. Some of the compost is sold commercially, but most of it is sold in bulk shipments to fertilizer companies, truck farms, and local farmers. This composting plant in California is not being operated partly because there is no market for the soil conditioner. Here, dairy wastes are a competing product and are cheaper to the farmer. Thus, composting usually is not thought of as a business, but rather as an alternative to incinerating or landfill operations, thus justifying municipal expenditure. Agricultural solid wastes involve huge volumes of manure, crop residues, and wastes from rural industries, such as fruit packing stands, canneries, and packing houses. This mountain of cow manure near Los Angeles has no market. Nationally,